Welcome to week 4 homework portal, and we are doing problems, one problem a day, and I will be putting across the solutions for this video every day. Okay, so there was some request made by a few students online who said that where do we get this question paper where you are solving, so can we have it in advance? So what I thought was that maybe when the first video is getting over, so I will put across the link also for this question paper, so you can download it for the whole week, and you can use it across. Okay, so without wasting our time, let me start with these questions. Let me start the timer. This is for 8 marks for the first day. So a jet aeroplane accelerates along the runway before takeoff at night. Okay, the regular flashes from the wing light or the moving aeroplane are photographed by a camera. Okay, so there is a what you call lights over here which keeps on blinking. So you are going to find out you're going to take the photo of this. Okay, so and for every there are two fixed lights AB along the runway 30 meter apart. Okay, so there are 2 meters over 30 meters apart. Okay, the moving light appears as a succession of this part, the R, S, T, U and V on the photographic film. Okay, so these are the points, or these are the times when the photographs were taken. The aeroplane is already moving by the time the first image R is recorded. Okay, the wing light flashes every 2 seconds. Every 2 seconds. Okay, fine. So that means I can now say this is for 0 second, 2 seconds, 4 seconds, 6 seconds, 8 seconds. Okay. Then the photograph also records the images of the two fixed lights A and B. Okay, A and B. Okay, and see if this is A and B, this is A and B. I can now say this should be 30 meter and this length should be larger than 30 meter. Okay, use this one to be having a comparison between these parts. Okay, you see this star and this star aligns over here. So this star is very much nearby here. So as a result of it, this should be larger than 30 meters. That's what it tells you. Okay. By making appropriate measurements on the photograph above, determine the distance on the runway represented by 1 millimeter on the film. Represented by 1 millimeter on the film. Okay. So there are two things that you need to find. So first question asked here is that find out what does 1 millimeter on the film represent. How much meters does it make? Do not just write 1 millimeter equal to 1 by 1000th of a meter. That's not the case here, because you are using a different scaling here. First thing, and secondly is asking you to find out the total distance on the runway. Okay, so now how do we do this? Now the question is, I need to have a scale to measure this length. Even in your paper, when you get such kinds of questions, you need to have a scale. So what I do is, I have got a scale online where I can put it across to my screen and then find out what is this. So it's here. So I'll pull the scale here. You can see the transparent one. I am pulling it over here, and then this is I'll pull it between. So I'll keep it between these two. When I keep it across here, this comes out to be somewhere around 26 centimeter. It's 26 centimeters. Okay, I'll write down something. I'll do one thing. I'll write it down here. So what are the lengths over here? So therefore, between the R and S, the distance is seen to be 26 millimeter. Right? 10, 20, 25, 26. It should be 26 millimeter. And then the next one, let me move the scale here. Keep it exactly at that point. And what is the value here? I get the value as 33.4 centimeter. Or maybe I'll make it as 33 millimeter. 33 millimeter. And I'll move this once again, coincide the 0 with the another star. And I get this here. So which should be, how much is 4.23 centimeter, which is 42 millimeter. 42 millimeter. And then the next one, I keep it over here. And I find this distance to be 5.08 or 51 millimeter. 51 millimeter. 51 millimeter. Okay. And also I want this one. So what I do is I pull this one here and keep it exactly here at this point. It seems to be 25 millimeter. So what does it say? It says 25 millimeter is equal to 30 meters as a reference. 30 meters as a reference, or in other words, 1 millimeter is equal to 30 divided by 25, which would be equal to 5 5s are 5 6 are, which would be equal to 6 by 5 meters. 6 by 5 meters. Okay, so this is what I have got. This is nothing but a scaling. Okay, now let us move on to the next one. Next is the average velocity of the aeroplane between R and S. Between R and S. Between R and S here. So what is the distance here? 26 millimeter, and time 2 seconds. So therefore, average velocity is 26 millimeter divided by 2 seconds, which is 13 millimeter per second. Now what should I do? I should convert it in terms of meters per second. This is for 3 marks totally over here. So I will convert this as 13 into what is the value of here? This value should be 1 millimeter 6 by 5 here, right? So this should be multiply this by 6 by 5. So when I do this, how much do I get? Let me use my calculator. Calculator here. Okay. So this should be 13 star 6 divided by 5 should be equal to 15.6. 15.6. Since I need only two significant figures, I will keep this as 16 meter per second, right? This is meters and this second, so 16 meter per second. Okay, now let us look at the next one. Point U1V. Points U1V. Where is points U1V? It's here. The distance is 51 millimeter here. So once again do the same thing. The next one, which is point U1V. Okay, now what we'll do is let us go for point U1V. What does it say? Between point U1V, it is 51 millimeter. Time taken is 2 seconds over here. So what is the average velocity here? So average age is 16 here, right? Okay. Average velocity is 55 millimeter divided by 2 seconds, right? Distance by time, which should now be 55 into, I need to convert into meters per second. It should be 6 by 5 divided by 2. So 2 ones are, 2 threes are, 5 ones are, 5 11s are. So answer should be 33 meter per second. Okay. Now, so what is he asking? Next one is the average acceleration of the aeroplane along the runway. Okay, average acceleration along the runway. So now this is 33 here, this is 33 here, and this is 16 here. Okay, so therefore distance between them, the time taken. So this is final velocity, initial velocity. 33 minus 16 divided by 1, 2, 3. That is 2, 4, 6, 6 seconds. So 33 minus 16 divided by 6 seconds. So your acceleration A is equal to 33 minus 16 divided by 6, which should be, let us take up our calculator once again. So this is 33 minus 16 is equal to 17 divided by 6 will be 2.83, 2.8 meter per second square. This should be your answer. Okay.